A surprising discovery made by the James Webb Space Telescope has captured the attention of the scientific world. The detection of urban light signals in space, located at a distance of 7 billion kilometers from Earth, has sparked great interest in the possibility of extraterrestrial life. By focusing on Proxima Centauri b, the closest exoplanet to Earth, the telescope revealed the presence of unusual bright lights emanating from its surface. What could be the cause of these unusual lights on Proxima Centauri b? Could they indicate the existence of life beyond our own planet? For years, mankind has longed and searched for signs of life beyond our own solar system. Any hint suggesting the possibility of this fantasy has been greeted with great enthusiasm. Recently, the scientific community was stunned when the James Webb Space Telescope captured compelling evidence for the existence of life forms in space. While exploring the cosmos and transmitting critical data back to Earth, the telescope observed unique urban lights coming from the exoplanet Proxima Centauri b. These lights, as their name suggests, are the first to be seen in space. These lights, as the name implies, appeared to illuminate a distant city. The idea of the existence of an alien civilization in this star system has perplexed scientists, filling them with wonder. Each is baffled by the possibility that this is a discovery they have been all waiting for. If confirmed, it would mean that there are intelligent life forms that have developed societies beyond our comprehension in our space, and we are just beginning to discover it. Absorbing these urban lights from a distance of 7 billion kilometers, NASA engineers wonder how long they have been glowing in space, waiting for mankind to develop the technology to detect them. David Kipping, an astronomer at Columbia University, characterizes the exoplanet Proxima b, where the urban lights have been sighted, as a celestial body with peculiar heating patterns that differ from those observed on other planets. While conventional rocky planets tend to absorb sunlight and emit infrared radiation, this exoplanet exhibits a markedly different infrared nature from its host star Proxima Centauri. This peculiarity has allowed careful observation by the James Webb Space Telescope JWST, since this instrument is highly sensitive to infrared wavelengths. The thermal signature of Proxima b will play a crucial role in investigating the universal secrets of its atmosphere. Taking advantage of the JWST's state-of-the-art infrared imaging capabilities, scientists plan to use this telescope to unravel the planet's atmospheric mysteries as well as to assess its potential habitability. The JWST, with its exceptional infrared sensitivity, is equipped to probe the nights on Proxima Centauri b because it can pick up even the faintest light signals in the cosmic darkness. It becomes the ideal tool for verifying the existence of possible city lights in the night of Proxima b. The JWST's ability to detect artificial illumination in the cosmos is due to its ability to operate within an extremely narrow frequency band, 1,000 times narrower than starlight. Proxima b exhibits an interesting relationship between its stellar features and its surface interactions, with its daytime side adorned with solar panels that harness the energy of its star, while its night side experiences cold temperatures. The temperature variation across Proxima b, as determined by its atmospheric composition, is an intriguing topic for astronomers, and the JWST can effectively probe the planet's thermal emissions to provide crucial data on its atmospheric properties. In addition, the JWST's orbit around the Earth aligns with the orbit of Proxima b, allowing full observations of its diurnal and nocturnal cycles in 11 Earth days. The next step will be to assess the atmospheric chemistry on Proxima b to determine its potential to support life, focusing on the presence of gases such as oxygen, water vapor, and methane as key indicators of habitability. If elements such as oxygen, water vapor, and methane are detected in the planet's atmosphere, it could mean that it's capable of supporting habitable conditions. However, this process is extremely challenging as it involves the meticulous capture and analysis of the light rays passing through the planet's atmosphere. Although the James Webb Space Telescope JWST has great capabilities for characterizing planetary atmospheres, its focus is primarily on analyzing variations in the concentration of water vapor, carbon dioxide, and methane. Detecting oxygen, a crucial indicator of life, is more limited for the JWST. Despite these limitations, the telescope still looks for other elements, such as ozone, which may also provide clues to the planet's habitability. It is important to keep in mind that the JWST cannot explore all potential habitable worlds as it has limited capabilities and can only observe some of the actual planets closest to Earth. Therefore, astronomers are turning to ground-based observatories, such as the extremely large telescope ELS, which is expected to become operational in 2028 and allow for a deeper investigation of the atmospheres of distant exoplanets. Scientists eagerly anticipate the development of future space telescopes that will expand our understanding of extraplanetary exploration. Although the JWST has limitations, it remains a crucial tool for unraveling the mysteries of distant exoplanets. However, future space telescopes will aim to reduce the glare from host stars in order to better study light reflections from the exoplanets themselves. This presents additional challenges, as scientists must distinguish between gases produced by life and those generated by geological processes on the planet. Despite these challenges, scientific advances continue to move forward, and the Webb telescope represents a step forward in our understanding of exoplanets and the universe in general. Despite an exhaustive search in all corners of space, scientists have not yet succeeded in finding any planet capable of supporting life. Throughout decades of research and the search for signs of life in the cosmos, the question still remains: are we alone in the universe? The James Webb Space Telescope has found evidence of human activity far from Earth, bringing us closer to answering the age-old question of our solitude in the universe. The research for extraterrestrial life has been a constant throughout human civilizations, generating thousands of literary works and theories on the subject. Our fascination with our place in the universe and the possibility of not being alone seems to be ingrained in us, driving us to seek companionship even if it's of extraterrestrial origin. We're getting closer and closer to finding answers to questions we really want. But are these answers really what we seek, or is there something deeper at play? In 2021, the JWST posed a hypothetical question about the future capabilities of our technology. Could our telescope detect artificial light on another planet, such as Proxima b? The exoplanet, the closest to Earth, lies in the habitable zone of our nearest neighboring star, Proxima Centauri, about 425 light-years away. Proxima b was believed to be locked in synchronous rotation, similar to the Moon with Earth, with one side always facing its star. The possibility was raised that a technological civilization on Proxima b could transfer the heat and electricity from the daytime side to the night side using photovoltaic cells that generated electricity from sunlight. Subsequently, a paper with Manas V. Lingam as one of the researchers showed that significant coverage of the daytime side with solar panels could be detected by future telescopes. Given that the James Webb Space Telescope represents a more advanced technological advance now in 2024, there is a possibility that will allow us to expand our research for possible artificial lights on habitable exoplanets such as Proxima b. Thanks to its increased sensitivity and range of capability, the JWST may have discovered the lights we've been looking for, which could propel humanity towards another great leap in its evolution. But before we dive into the implications of the discovery, it is crucial to understand how this feat was possible. The James Webb Space Telescope mission explores the mysteries of Proxima Centauri b. Throughout history, humankind has sought answers to understand the fundamental questions about the universe, our existence, and destiny. These common but extremely difficult questions have driven humanity's curiosity for as long as we have been conscious. In the current era of exponential technological advances, the question arises as to whether we are any closer to finding answers. While a philosopher might argue that we are still at an early age in our understanding of the universe and ourselves, an astronomer would be excited to share the latest discovery about the cosmos using the technological tools at his or her disposal. Although these advances often go unnoticed by the general public, they truly represent milestones in human evolution. Now, with the world literally at our fingertips, it is time to move forward and explore the universe in ways never before imagined. One of the ways of exploration is through technologies such as the James Webb Space Telescope. This instrument, heir to the legacy of human space exploration, is destined to answer fundamental questions about our place in the cosmos. It has already begun to shed light on the possibility of life beyond our solar system, as evidenced by the recent discovery of possible lights on a planet light-years away. Proxima b, also known as Proxima Centauri b, is a super-Earth exoplanet orbiting an M-type star. These planets, more massive than Earth but lighter than ice giants like Neptune or Uranus, are a unique class in the universe. Although much remains to be discovered and understood about Proxima b, this breakthrough represents a significant step forward in our quest to better understand our place in the cosmos. The first possible evidence of an exoplanet dates back to 1917. Although at that time it barely captured the attention and recognition of the scientific community. However, it was in 1992 that the first detection of an exoplanet was confirmed, astounding scientists. Since then, many other exoplanets have been confirmed, with another notable example in 2003. By April 1, 2024, a total of 653 exoplanets have been confirmed in 161 planetary systems, of which 196 have more than one planet. These marvelous discoveries are mostly associated with M-type stars, also known as red dwarfs. Red dwarf FS are the smallest stars on the main sequence that are considerably more common in the Milky Way than other stars. However, due to their low luminosity, observing them is not as easy as with other stars. Red dwarfs have different classifications and names according to their temperature and sizes, often designated as M dwarfs. The stars with a temperature of about 3900 Kelvin have specific characteristics that distinguish them, such as Proxima b, whose mass is estimated to be about 107 times that of Earth. Remarkably, it completes an orbit around its star in only 11.2 days compared to our Earth year of 365.25 days. This gives us an estimate of the size of the star orbiting Proxima b. The star's luminosity is surprisingly low across the magnetic spectrum at only 16% of the Sun's luminosity. Moreover, in the visible spectrum, its luminosity appears even dimmer, emitting only about 0.56% of the Sun's luminosity. More than 85% of the energy it emits is in the form of infrared radiation, and it orbits at a distance of about 2,856 astronomical units from its star. The discovery of Proxima b was announced in 2016, which raises the question of why this particular exoplanet has generated so much interest. One of the reasons is that Proxima b is the closest known star to our Sun, albeit at a distance of 42 light-years, which, while large to us, is relatively short on a cosmic scale. It is part of the triple star system known as Alpha Centauri, and despite its low luminosity, remains an object of great interest to astronomers. The Proxima Centauri system stands out as one of the constellations visible in the night sky, ranking behind only two others known as Sirius and Procyon. However, the most intriguing thing about Proxima Centauri b is its potentially habitable position within the habitable zone of its star. Possibilities, they suggest, are limitless, which has led astronomers to embark on an expedition to explore the depths of this stellar potential. This is where the James Webb Space Telescope comes in. The four main goals of the JWST include searching for light from the first stars and galaxies that formed after the Big Bang, studying the formation and evolution of galaxies, understanding the formation of stars and planets, and investigating planetary systems and the origins of life. As JWST continues its exploration of exoplanets such as Proxima b, we move ever closer to achieving these goals. The search for extraterrestrial life is a particular area of interest in space exploration. The search for extraterrestrial intelligence SETI project stems from the curious nature of humanity, exploring all that moves and all that does not. SETI imagines a kind of cosmic treasure hunt where, instead of gold, we are in search of electromagnetic signals that could be whispers of civilizations beyond our wildest imaginations. Work has been going on for several years to develop technologies for space observation, and today, amazing machines such as the James Webb Telescope have been built. This telescope has left the whole world in awe with its new images of deep space and its amazing discoveries. The telescope uses very powerful space lenses that make it possible to see the first galaxies and stars that formed billions of years ago. After a long period of design and construction, and after several setbacks, the James Webb Telescope is finally producing its first results, representing the impressive result of an investment of about $10 billion. We invite you to join us to explore how this telescope has achieved a clear image of Proxima b. If you're interested in keeping up to date with news about the universe and its surroundings, subscribe to our channel, be sure to like this video, and turn on the notification bell. Thanks to the James Webb Telescope, NASA and its international partners have been able to prove that many of the theories that we hold are true. The telescopes will make it possible to observe phenomena and stars that until now were totally unknown to space science. The largest telescope ever built was launched into space on December 25, 2021. It is currently located at the L2 Lagrange point, 15 million kilometers away in the Sun-Earth halo orbit. Thanks to a 6.5-meter-wide primary mirror and ultra-sensitive infrared instruments, the telescope has been able to detect the deep red shapes of the galaxies that existed 600 million years after the Big Bang. The universe is approximately 13.8 billion years old, and the news that scientists can interpret from the quality of information being produced by the James Webb is that the telescope is receiving information about the universe far beyond what has been expected so far. This may be the deepest visual range of the universe we have ever obtained. James Webb STC has achieved a feat never before seen in human history by capturing images of the cosmos that surpass any previous expectations. The first images released by NASA offer a completely new vision of the universe, which surprised even the experts. The goal of this mission is to solve the mysteries of the solar system, discover new worlds, and explore the origins and structures of the universe. NASA has worked in collaboration with the European Space Agency, the Canadian Space Agency, and other international agencies to make this project possible. The telescope has captured a hidden history of the universe through every stage of its evolution, which allows scientists to better understand our place in the universe. In the images captured by the James Webb, exoplanets and distant galaxies can be seen in the deep universe, making it the clearest and most detailed infrared image of the distant universe today. The first color photograph taken by the telescope was released on July 12, 2022, and did not disappoint expectations. The image, revealed by President Joe Biden, shows the telescope's ability to fulfill one of its goals, which is to observe distant galaxies. The image shows a cluster of galaxies in the Boötes constellation, known as MAX 0723, which lies at a distance of more than 4.5 billion light-years. The light reaching us from this galaxy was generated when the solar system was forming, and it has traveled across the universe until it reaches us today. What is an exoplanet? Well, an exoplanet is a planet that orbits a star other than the Sun and therefore does not belong to the solar system. Of all the exoplanets known so far, none arouses as much interest as Proxima b. As mentioned before, the star orbiting this exoplanet is Proxima Centauri, a very cold red dwarf with a surface temperature of 2872 C. It is 8 times less massive than the Sun and 500 times less bright. About 7 million kilometers from its star is Proxima b, which has characteristics very similar to those of the Earth, with continents, oceans, and probably life, with huge auras giving the planet a greenish color. In both atmospheres, as a result of the intense flares expelled by its star, the magnetic field generates these huge auras. What you see on the screen is the most detailed image that the James Webb Telescope has ever taken of Proxima b. This planet is tidally locked, that is, the same face of the planet always points to its star. This means that the best area for life is a twilight zone. The surface temperature could be between 90 C and 30 C, and it takes about 11 Earth days to complete a full orbit of its star. It has a gravity of about 123 times that of the Earth. Scientists are not yet clear whether Proxima b has an atmosphere, but if it does, the ingredients such as carbon dioxide, rocks, and water necessary for the formation of the biochemical cycles we call life would be present on its surface. The James Webb Telescope has succeeded in finding signs of water on an exoplanet called WASP 96b. The spectrum of this exoplanet's atmosphere has been analyzed in detail by the telescope, revealing the presence of water, haze, and clouds that had not been detected before. Although WASP 96b orbits too close to its star to harbor life, scientists hope that Webb will be able to study planets with Earth-like atmospheres in the future. Looking for signs of life, NASA experts are very confident that Webb will meet its goals. The first list of images released by the telescope is spectacular and has been captured in infrared, including photos of the Southern Ring Nebula, a star covered in dust and light. The scientist in charge of the project, Dr. Embastron, is excited about what they will be able to do with these images in the future. The James Webb Telescope gives us a stunning view of the Stephan's Quintet, a group of galaxies in the constellation of Pegasus, with clouds of dust surrounding its center. Stephan's Quintet is composed of 5 main galaxies: NGC 7317, NGC 7318A, NGC 7318b, NGC 7319, and NGC 7320. These galaxies are gravitationally interacting with each other, which has resulted in interesting and peculiar features in their structure. NGC 7317 is an elliptical galaxy that appears to be relatively isolated from the rest of the group. NGC 7318A and NGC 7318b are 2 merging galaxies that have generated intense star formation activity. NGC 7319 is a barred spiral galaxy with a deformed spiral arm due to interactions with the other galaxies in the group. Finally, NGC 7320 is a smaller spiral galaxy that appears to be farther away from the group and not interacting as directly with the other galaxies. Stephan's Quintet is an interesting object of study for astronomers as it offers an opportunity to better understand how gravitational interactions can influence the evolution of galaxies. These interactions can trigger star formation, deform galactic structures, and eventually lead to mergers between galaxies. The studies of compact groups of galaxies such as Stephan's quintet help expand our knowledge of galaxy formation and evolution in the universe. In addition, through its view of the Carina Nebula, Webb gives us a rare view of stars in the early stages of formation, studying the gas and dust that create them. Webb's ability to detect essential molecules will be vital for searching for organic traces on exoplanets. The telescope will continue to orbit and provide images and data of the universe, and it is hoped that in the future it will be able to study a planet with an Earth-like atmosphere in search of life. Although we cannot predict exactly what Webb will show us in